Hi students, today we are going to see two more theorems on chapter circles, right? And this is also property, right? Property alone. So you have to keep in your mind, right? Already we have discussed two property. What are they? One is named based an angle, and the one is named based on side, right? Theorem 3, prove that into concentric circle. What is meant by concentric circle? Same center with different radii, right? We are drawing a circle with the same center point with a different radii, right? Different radii. If we have drawn with the same radii, then we'll get only one circle alone. With a different radii alone, we'll get so many circles with the same center. That is very important. That is called concentric circle. Okay. Prove that in two concentric circle, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. That means what we want to prove that. See, we want to draw the chord for the bigger circle, right? That we want to draw chord for the bigger circle. That chord should be touches the smaller circle at the point of contact. And we want to prove that the chord is bisected at the point of contact, right? The chord is bisected. That means we want to prove that AC is equal to BC. See, AB is nothing but chord of the bigger circle touches the smaller circle at the point of contact. Point of contact is nothing but C point, right? Point of contact is nothing but C point. So we want to prove that AC is equal to BC. That means AC is equal to BC. That is the chord bisected, right? The chord is bisected. What is bisected? Divided into two equal parts, right? That only we want to prove that, right? So right, first given two circle with the same center O. Two circle, right? First circle and second circle with the same center O, and AB is the chord of the bigger circle, right? AB is the chord of the larger circle touching the smaller circle, right? Touching the smaller circle at C, at the point of contact C, right? To prove, what we want to prove that AC is equal to BC, right? We want to prove that the point C is bisecting, right? The point C is bisecting the chord AB, that is AC is equal to BC, right? AC, to prove, we want to prove that AC is equal to BC. So for that, what I am doing, I am just a construction, right? I am just doing the constructing. I am just joining the OC, right? OC, join OC, right? Now I'm going to do the proof, right? So how I'm going to do the proof means very simple, right? See, OC is the radius and AB is something but tangent to the small circle, right? AB is a chord for the bigger circle, but here, right, for the small circle, the line AB is nothing but tangent, right? Tangent to the small circle. Then the C is nothing but point of contact. Then OC is nothing but radius, right? So OC, if then using the first property, what is the first property? Radius, right? The OC is perpendicular to the tangent. OC is perpendicular to the tangent, that is right angle, right? If AB is the tangent to the small circle, right, and OC is nothing but radius and C is nothing but point of contact, then we will say that OC is nothing but perpendicular to AB, right? Then only I am just going to explain. See, AB is a tangent to the smaller circle at the point C, and OC is the radius through C. Therefore OC is perpendicular to AB. Therefore OC is perpendicular to AB. But the perpendicular, see that this is also last year you have studied that the perpendicular drawn from the center, center of a circle to the chord, right? And first AB is something but see, AB is a tangent to the smaller circle and AB is the chord for the bigger circle, right? See, we have to differentiate. So AB is nothing but, for smaller circle AB is nothing but tangent, for bigger circle AB is nothing but chord, right? For bigger circle, right? Okay, see, there is a perpendicular. OC is nothing but perpendicular, right? OC is a perpendicular. How we are saying that OC is perpendicular? By using the tangent property, right? By using the tangent property, we can say that OC is perpendicular to AB, right? So the perpendicular drawn from the center of the circle, right? The perpendicular drawn from the center of a circle to a chord bisects a chord. To a chord, by last year, this property you have studied in the last year, right? From the center point to the chord, if you have drawn perpendicular, then it will be bisected. It will be means which one will be? The chord will be bisected. That only we have said that, right? But the perpendicular drawn, right, the perpendicular drawn from the center of a circle to a chord bisects a chord. To a chord bisects a chord. Therefore, OC bisects AB. Therefore, OC bisects AB. That is, AC is equal to BC. Hence, it is understood. So, see, from this you have to know, you are studying new property. What is the property? When we are having two concentric circles, right? When we are having two concentric circle, right? When we are having two concentric circle, the chord of the larger circle, right? The chord of the larger circle will be bisected. The chord of the larger circle, right, will be bisected. That is the third property. So first property is something based on an angle, right? So first property is nothing but a tangent at any point of a circle, right? A tangent at any point of circle is perpendicular to the radius to the point of contact, right? Radius to the point of contact. The second point is nothing but from the external point, right? When we, there is a only possible for drawing two tangents, right? The two tangents, the length of the two tangents are equal, right? That is second property. Now we are studying the third property. What is the third property? In two concentric circle, right, the chord of the, right, the chord will be bisected. The chord of the bigger circle, right, the chord of the bigger circle will be bisected. That is, AC is equal to BC. By using this property, they will ask you in 1 marks, right, ask you to find the value of, what is it, ask you to find the value of the length of the chord. Likewise, they will ask you. So you have to keep this property in your mind. Then only it will be very easy to use when they are asking, right? The next theorem number 4. Theorem number 4, and this theorem is very important, right? So many times they have asked in 2 marks, right? This is very easy only. So many times they are asking in the 2 marks, right? 2 marks, very easy only, right? Okay. Prove that the tangents drawn at the end of the diameter, right? End of the diameter of the circle are parallel. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. So I am just drawn the circle, right? Center point O. I have drawn that diameter, right? Here AB is something but what is it? Diameter, right? So from that A point and B point, we want to draw the tangents, right? So CD and EF are the two tangents. CD and EF are the two tangents. So what we want to prove that? We want to prove that CD is parallel to EF. Understood? CD is parallel to EF. So AB is nothing but diameter of a circle with center O, and CD and EF is nothing but tangent, right? Tangent. CD and EF is nothing but tangent. What we want to prove that? We want to prove that CD is parallel to EF. So write the given CD and EF are the tangents. CD and EF are the tangents at the end points of A and B of diameter AB of a circle with center O. Right, this is given to prove what we want to prove, that CD is parallel to EF. CD is parallel to EF, right? Proof. CD is a tangent, right? CD is a tangent to the circle of the point A. CD is a, see how I am going to prove this. These two tangents are parallel means very simple, by using the property. What property I am going to use means, see, this is the what is it? CD and EF are two lines, right? Two lines, and AB is the transversal. Sum of, what is it? Not sum of, alternate interior angles are equal, right? Alternate interior angles are equal, then the two lines are parallel, right? Alternate interior angles are equal, then the two lines are parallel. So CD, EF is nothing but two lines, and AB is nothing but transversal, right? Transversal. And by using the property alternate interior angles, right? If the two alternate interior angles are equal, then CD is parallel to EF. That only I am just going to prove that. So first I am taking the first tangent CD, right? CD is the tangent to the circle at the point A, right? So we know that what is it? CD is the tangent, then OA is nothing but what is it? Perpendicular to CD, right? OA is nothing but perpendicular to CD is perpendicular to OA, right? CD is perpendicular to OA. That means angle OAD is equal to 90 degree. OAD is equal to 90. If angle OAD is 90 degree, then I can say that angle BAD, right, from B to BAD, right, angle BAD is equal to 90 degree. Same thing. OAD is 90 degree. Then from the line B onwards, right, from the line B onwards, BAD is also what is it? The angle is nothing but 90 degree, right? You just keep it as equation number 1. Next time, just taking the next tangent. EF is the tangent to the circle of the point at the point B. EF is the tangent at the circle at the point B, right? Now we know that what is it? OB is perpendicular to EF, right? OB is perpendicular to EF. That means Angle B is nothing but right angle. OBF is nothing but, sorry, OBF or OBE, whatever it may be. OBF or OBE, right? I'm just taking this one. Both are 90 only. OBE is nothing but, what is it? 90 degree. If angle OBE is nothing but 90 degree, then we can say that ABE is also, what is it? 90 degree, right? ABE is also 90 degree, right? Take it as equation number 2. Now see that, just compare equation 1 and 2, alternate interior angles, right? So these two are 90 degree. So angle BAD is equal to angle angle ABE. Both each 90 degree, right? Each 90 degree. Now see that DAO or OAD and OBE, what are they? These two are interior angles, right? Alternate interior angles. But these are alternate interior angle. When it will be equal, when the two tangent, the two lines are parallel, that is CD is parallel to EF, right? So from this theorem also you want to know, you have to thorough one property, right? The tangents drawn at the end of the diameter of a circle are parallel, right? The tangents drawn at the end of the diameter, right? Drawn at the end of the diameter of a circle are parallel, right? So this property we will use for the proof, right? Not for finding the values. This property we will use for the proof, right? So just keep in your mind. And still we are going to see two more sums. From the sum also we are going to study the new property, right? Going to study the new property, right? Now we are going to prove, that is also proof only, right? That is also proof, not theorem, but we are going to prove how we are going to prove this is equal to that. Likewise we are going to prove. From that we are going to study the new property, right? Sum number 6, right? A quadrilateral ABCD, so ABCD, this is the quadrilateral ABCD is drawn to circumscribe. That means, what is it? Inside the quadrilateral, what is it? Circle is there. Inside the quadrilateral, circle is there. And the circle is also, what is it? Touching the four sides of the quadrilateral. That is nothing but circumscribe, right? Inscribe is nothing but a quadrilateral inside the circle. Circumscribe means a circle is touching the four sides of a, right? A circle is touching the four sides of a quadrilateral, inside the quadrilateral, right? So a quadrilateral ABCD is drawn to circumscribe a circle, right? Circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. AD plus BC. So from this proof also, right, we want to prove, now we are going to prove that AB plus CD, right? AB plus CD is equal to AD plus BC. AD plus BC. So from this proof, what property we are going to study means, before proving itself, I'm just explaining, I'm just saying that, just keep it in your mind, this is very important. Sum of two opposite sides, right? Sum of two. See, when a quadrilateral is circumscribed to a circle, right, then only this property will be applicable. What does that mean? Sum of two opposite sides is equal to sum of the other two opposite sides, right? AB plus CD, right? AB plus CD is equal to, right? AB plus CD is equal to AD plus BC. These two are opposite sides, right? These two are the opposite sides and these two are the opposite sides. So it will be equal. When it will be equal? When the circle, when the quadrilateral is circumscribed by a circle, then sum of two opposite sides is equal to sum of the other two sides, other two opposite sides, right? So next, fifth property, right? So just keep in your mind, sum of two opposite sides is equal to sum of two other two opposite sides, right? When, yes, a quadrilateral is circumscribed to a circle, right? So I'm just going to prove that. So how I'm going to prove means by using the second property. What is the second property? The length of the tangents drawn from an external point are equal, right? The length of the tangents drawn from an external point are equal. So in this, here this is the image circle with center O. Here how many external points we are having? See, A is in the image one external point, B is in the image another external point, C and D, right? And see how many tangents we are having? 4 tangents. And we have to give the name for the point of contact, right? So I give the name for the point of contact. See here, this is in the image P, right? And here Q, and this is in the image R and S, right? Point of contacts. See here we are having 4 tangent AB, BC, CD and DA, 4 tangents as well as 4 external points, right? Not 4 tangents, right? See, we are having so many tangents. See how many external points we are having. We are having 4 external points, right? A, B, C, D. For each external point to the circle, we are having 2 tangents. That the length of the 2 tangents are equal, right? Here AP is equal to AS. These two are equal. From the external point, BP is equal to BQ. BP is equal to BQ, right? And see, CQ is equal to CR. These two will be equal, right? CQ. By using the property, what is the property? The length of the tangent, right? The length of the tangents drawn from a external point to a circle, right? The length of the tangent drawn from a external point to a circle are equal. That means CR is equal to CQ. Same thing, dr is equal, right? Dr is equal to ds. These two are equal. Understood? So see that as from an external point A to the tangent, right, to the circle. Tangent to the circle is nothing but as is equal to AP. These two are equal. Same thing, PB is equal to PQ. These two are equal. Understood? This is very important. So this is the external point. So how many external points? We are having 4 external points. For each external point, we are having 2 tangents. The 2 tangents are equal. See, once again, I am just repeating. Why? Because this is the first sum. So from that sum itself, you want to know that, right? What property we are using. By using that property alone, we are going to prove that, right? So see that A is nothing but external point for the circle. So from the A, we can draw 2 tangents, that is nothing but AS and AP, right? AS and AP, that AS and AP are equal, right? These 2 tangents are equal. Same thing, B is nothing but external point. So from the point B, we can draw 2 tangents, that is BQ and BP, right? BQ and BP are 2 tangents, right? BQ and BP are 2 tangents, right? BQ and BP are 2 tangents. Same thing, C point for D point also, right? So now we can go for the proof, right? In quadrilateral ABCD is circumscribed by a circle such that the sides AB, BC, CD and DA are touching the circle at P, Q, R and S respectively, right? I have written whatever we have written the words, right? Now see that A is nothing but external point. So AP and AS are the tangent, right? So AP and AS are tangents from the point A, right? AP and AS are tangents from the point A to the circle. Therefore, what is it? AP is equal to AS, right? AP is equal to AS. Next, I am just taking the B point. Now, what is it? BP and BQ, right? BP and BQ. BP and BQ are tangent, right? BP and BQ are tangents. BP and BQ are tangents from the point B, right? From the point B to the circle, right? From the point B to the circle. Therefore, what is it? These two are equal. BP is equal to BQ. Next, I am just taking the C point, right? So, what is it? CR and CQ, right? CR and CQ, right? CR and CQ are tangents from the point. CR and CQ are tangents from the point. Which point? From the external point. Which point? From the point C, right? From the point C to the circle. That means, what is it? CR is equal to CQ. CR is equal to CQ, right? Just take this equation number 1, right? This is equation number 1, equation number 2, and this is equation number 3. Still we are having one more point, that is in the D point. So DR is under DS, right? DR and DS are the tangents drawn from the point D to the circle, right? DR and DS. So similarly, shall I put similarly? Directly I am putting similarly. Similarly, DR is equal to DS. DR is equal to DS, right? Equation number 4. Now just a sum of adding all we get. You just add all the 4 equation, right? Just add all the 4 equation. Just LHS fully you can add separately. RHS fully you can add in the right hand side. Then you will get the proof, right? Now I am adding all the 4 equation. Then LHS. What are the LHS we are having for the first equation? AP plus BP plus CR plus DR, right? AP plus BP plus CR plus DR, and adding the RHS, AS plus BQ plus CQ plus DS. AS plus BQ plus CQ plus DS. Now see that AP plus BP. What is AP plus BP? AP plus BP. So write as AB. AP plus BP is nothing but AB, right? So instead of this, I'm writing AB, right? AB plus CR plus DR. CR plus DR. So I write CD. CD is equal to AS plus DS. What is AS plus DS? AS plus DS. AD, right? AS plus DS is nothing but AD plus BQ plus CQ. That is nothing but BQ plus CQ is equal to what is it? BC. See, actually what we want to prove, AB plus CD is equal to AD plus BC. That only we want to prove, right? AB plus CD is equal to AD plus BC, right? AB plus CD is equal to AD plus BC. Hence it is. Understood? So from this property, right? So from this proof, we are learning a new property. What is the name of the property? We don't have name. What is the property? It is nothing but in a quadrilateral circumscribing a circle, right? The sum of two sides. See, what is the condition? Yes, a quadrilateral should be circumscribing a circle, right? Circumscribing a circle, then sum of two sides, right? Sum of two opposite sides of a quadrilateral is equal to sum of the other two opposite sides, right? So among the four sides, they have given only three sides and ask you to find one side. By using this property, we can find it. By using this property, see, suppose they ask you to find, we are having four sides of a quadrilateral, right? They are giving only three sides and ask you to find one side, right? The remaining one side. Then by using this property, we can find the fourth side of a quadrilateral, right? Next sum number 7. Sum number 7. In the given figure, a triangle ABC circumscribes a circle such that the sides BC, CA and AB touch the circle at D, E and F respectively. So that AF plus BD plus CE is equal to AE plus BF plus CD. Second subdivision, AF plus BD plus CE is equal to half of perimeter of triangle ABC. Half of perimeter of triangle ABC. So now we are having a triangle inscribed a circle or circumscribes a, right? A triangle circumscribes a circle, right? A triangle circumscribes a circle, right? Now we are having, what is it? Three external point, right? A, B, C are three external point, right? So from the point A, we are having two tangent, AF and AE. These two are tangent. These two will be equal, right? These two will be AF is equal to AE, right? And B is external point. From the B point, we are having two tangent. BF is equal to BD, right? BF is equal to BD. And from the external point C, we are having two tangent, that is CE and CD. So these two are equal, right? CE and CD are equal, right? So with the help of this, by using this property, we want to show that AF plus BD plus CE is equal to AE plus BF plus CD, right? And second proof, right? I told you already, by this proof also we are going to learn a new property, that is nothing but second subdivision, right? The perimeter of triangle ABC is nothing but two times of the tangent of each side. Tangent of each side. So we are having three sides of a triangle, right? For the each side we are taking one tangent, right? We are having three sides, right? We are having three sides, right? Among the three sides, right, we are having two tangent. For each side we are having two tangent. For that we want to take one tangent, right? We have to take one tangent, right? Three different tangent is equal, right? Sum of three different tangents of a triangle is equal to half of the perimeter of triangle ABC. This is the property. Understood? Sum of the three different tangent. Totally we are having three different tangent, right? Six tangents we are having. Among the six, three different, right? These two are same, these two are same, these two are same. So how many different tangents we are having? Three different tangents. So sum of three different tangents is equal to half of the perimeter of triangle ABC. Understood? Okay, now I am going to prove that same thing by using the property. So if A is the external point, right? If A is the external point, then AF and AE, tangent AF and AE are the tangents from the point A. Therefore AF is equal to AE. Similarly, same thing, BF is equal to BD, CD is equal to CE. Then sum of the three equation, you will get what is it? LHS is equal to RHS, right? Next, second proof also same like that, right? We will prove first. The given figure, AF and AE are, right? AF and AE are tangents from the point A, right, to the circle. Tangents from the point A to the circle. Therefore, AF is equal to AE, right? Similarly, B is in the what is it? B from the B external point, BF is equal to BD. So similarly, I am just writing BF is equal to, right? BF is equal to BD, or BD is equal to BF. BD is equal to BF. And similarly, what is it? CE is equal to CD, right? CE is equal to CD. Similarly, understood? From the B point, BD is equal to BF. From C point, CE is equal to CD, right? So take it as equation number 1, equation number 2, equation number 3. Adding equation 1, 2 and 3, we get, what we'll get? AF, just add AF plus, just add the LHS of this 3 equation, AF plus BD plus CE is equal to AE plus BF plus CD. See what we want to prove? AF plus BD plus CE. AF plus BD plus CE is equal to AE plus BF plus CD. So first proof is over, right? Second proof. What is the second proof? What we want to prove that AF plus BD plus CE is equal to half of perimeter of triangle ABC. For this also we want to say that, what is it? If A is the external point, then AF and AE is tangent to the circle. B is the external point, then BF and BD are the tangents. BF is equal to BD, like this we have to say, but directly we are using, right? We have written already. So by using that, I am just going to prove that AF plus BD plus CE is equal to half of perimeter of triangle ABC. So how I am just going to prove means, see, first I am just taking that perimeter of triangle ABC. What is the formula of perimeter of triangle ABC? Perimeter of triangle ABC is equal to, what is meant by perimeter of triangle? Sum of three sides of a triangle. Sum of three sides of a triangle. So what are the sides we are having? AB plus BC plus CD. Sorry, AB plus BC plus CA. Perimeter of triangle AB is the reason given AB plus BC plus CA. Sum of three sides of a triangle, right? So see that AB, how we can write AB? AB is nothing but AF plus FB, right? We can write the AB in terms of, what is that? AF plus FB. So AB is nothing but AF plus FB, right? AF plus FB plus BC is nothing but BD plus DC, right? BD plus DC. I'm just writing BD plus DC plus CA is nothing but CE plus EA. CE plus EA. Just see that what we want to prove, that AF plus BD plus CE is equal to half of the perimeter of triangle ABC. So I'm just converting this RHS in terms of AF, BD and CE, right? I'm just converting. So what is it? AF already we are having. What is FB? FB or BF? BF is nothing but, what is it? So BF, it's not needed, right? BF is on, see, AF is needed, and next BD is needed, right? BD is needed, AF, BD is needed, and next CE is needed, right? See, FB, DC and EA is not needed. So already we know that, what is it? BF is equal to BD. Instead of BF, and what I am substituting? BD, right? Instead of BF, and what I am substituting? BD. Instead of DC or CD, right? DC, what I am substituting? CE, right? Instead of EA, right? Instead of EA, what I am substituting? AF, right? AF plus BD plus BD plus CE plus CE plus AF. Understood? AF instead of FB, I have substituted BD. BD I have written as it is. DC, instead of DC, what I have substituted? CE plus, instead of EA, AF, right? Now see that AF, it is equal to 2 times of AF, right? Plus BD, 2 times of BD, like terms, right? CE, 2 times of CE. What is that in LHS? Perimeter of triangle ABC, right? Perimeter of triangle ABC equal to 2 times of AF plus 2 times of BD plus 2 times of CE. All the 3 terms, what is the common term? 2 alone. Just take 2 commonly outside. So AF plus BD plus CE. Just taking this 2 to the LHS. What is already in LHS? Perimeter of triangle ABC. So it is equal to AF plus BD plus CE is equal to half of the perimeter of triangle ABC. Perimeter of triangle ABC. Taking 2 to the LHS, right? It will goes to denominator. It is in the form of multiply. It is goes to LHS. It will be divide. So 1 by 2 into perimeter of triangle ABC is equal to AF plus BD plus CE. That only we want to prove. Hence it is understood. So from this proof, We are learning a new property, that is nothing but the sum of three different tangents of a triangle is equal to half of the perimeter of triangle ABC, right? And today homework is nothing but you have to complete the classwork, right? All the sums, all the sum number 6 and sum number 7, as well as the theorems also. And today homework is nothing but thorough this all the two theorem and these two sums, and write it in your rough note and send it to me. That is your homework, right? Thank you.